Ballistic Missile Defense Organization, BMDO, awarded a competitive contract to the McDonnell Douglas Aerospace Company to design, build, and flight test within 2 years an experimental technology demonstration vehicle, a liquid-fueled, fully reusable single-stage rocket system. This vehicle, the Delta Clipper Experimental DCX, would be primarily designed even in this early experimental stage for operability and supportability of the complete system. Forming a small, highly motivated team of designers, engineers, and technicians, BMDO and the McDonnell Douglas-led contractor team rapidly began developing a single-stage rocket technology, SSRT, flight system, including the rocket-powered flight vehicle, the control center, and the ground support elements. In just over 18 months, in early April 1993, the DCX was designed, engineered, built, tested, and rolled out at the McDonnell Douglas plant in Huntington Beach, California. Following rollout, the entire DCX system was transported to NASA's White Sands test facility in New Mexico. At the NASA White Sands test facility, the DCX system successfully underwent complete functional and operational test and evaluation. This included loading and flowing the liquid hydrogen and oxygen propellants through the transportable ground support system into the vehicle, exercising all the vehicle's major systems and subsystems according to the planned flight test mission profiles, and test firing of the 4 Pratt & Whitney RL-10A5 main engines and the Aerojet reaction control system motors through a full mission sequence. A total of 3 propellant loadings and 9 engine firings were accomplished using the same equipment and procedures to be followed during the actual flight tests. These tests were all controlled by the 3-person Flight Operations Control Center crew, using a unique automated system designed to fully control the flight of the DCX. These tests, averaging just over 2 days between full system engine firings, demonstrated early on the DCX's operability, supportability, and maintainability features. The rapid turnaround potential for this class of vehicle was demonstrated when it performed 2 engine firing tests within an 8-hour period. Upon completion of these important ground tests, the entire DCX system, Ground Support System, Flight Operations Control Center, and the DCX were transported from the White Sands Test Facility to the U.S. Army's White Sands Missile Range in preparation for the flight test series. This in itself was an important milestone in the SSRT program goals by demonstrating the transportability of a complete rocket system. Once at the SSRT site, the flight control, launch and landing area, and the DCX itself had to be prepared and checked out prior to beginning the flight tests. The test site activation process culminated with a successful hot firing, a short burst at minimum thrust level, fully verifying the readiness of all parts of the SSRT DCX system to begin flight testing. System readiness to begin the flight test series was announced on August 14, 1993. On August 18, 1993, the DCX lifted off its flight stand on an abbreviated hover test to verify the stability of the guidance, navigation, and control system. This is somewhat akin to a new aircraft's high-speed taxi check prior to its maiden flight. Following engine start while on the flight stand, the DCX accomplished a self-check of all systems and was throttled up for takeoff. Climbing to 150 feet above the White Sands dry lake bed, the DCX hovered and was then commanded to fly 350 feet to the west, placing it directly over the 100-foot square landing area. The DCX then performed a fully powered, controlled descent. The first controlled rocket-powered vertical landing of a fully reusable launch vehicle was successfully completed.
And drains closed.
10, 9, 8, 7, 6, 5, 4, 3, 2, start.
We have ignition.
We have liftoff.
We have engine throttle up.
Ascent is good. We're into translation mode. Pitch is going. It's looking good. 15 feet a second. It's looking good. Translation's looking good. Tracking right down there. "30 seconds. Looking good.
Tank pressure's holding strong.
Go on hover. Landing low thrust.
Landing gear deployed.
Landing Q limit. Landing high thrust. Acceleration ramp down.
Throttle up.
We got a touchdown.
Touchdown. Wait on gear. Wait on gear. Engine shut down. Engine shut down.
All right.
We did it!
Post landing.
Post landing. And drains closed.
10, 9, 8, 7, 6, 5, 4, 3, 2, start.
We have ignition.
We have
We have throttle up. We have engine throttle up.
Ascent is good. We're into translation mode. Pitch is going. It's looking good. 15 feet a second. It's looking good. Translation's looking good. Tracking right down there. "30 seconds. Looking good.
Tank pressure's holding strong.
Go on hover. Landing low thrust.
Landing gear deployed.
Landing Q limit. Landing high thrust. Acceleration ramp down.
Throttle up.
We got a touchdown.
Touchdown. Wait on gear. Wait on gear. Engine shut down. Engine shut down.
All right.
We did it!
Post landing.
Post landing.
Seconds. 45. 40. TM bit ground pass, vehicle pass. 30.
Drains closed.
20. 15. 10, 9, 8, 7, 6, 5, 4, start and check engines. 2, 1, launch and flight. Seconds. Translation. 15 15 feet a second, looking good. Halfway through. Starting the pitch maneuver. Landing low thrust. Landing Q limit. 200 feet.
Gears down.
Landing high thrust. Cell ramp down. She's looking really good. -6, -4, -3. Small negative.
Wait on
She's
gear.
on the ground.
Engine shut down.
Post landing. Heaters are off. Engine out monitoring process initiated. Launch commit process initiated. 50 seconds. 45. 40. TM bit ground pass vehicle pass. 30.
Drains closed.
20. 15. 10. 9. 8. 7. 6. 5. 4. Start and check engines. 2. 1. Launch and flight. Seconds. Translation. Feet a second, looking good. Halfway through. Starting the pitch maneuver. Landing low thrust. Landing Q limit. 200 feet.
Gears down.
Landing high thrust. Cell ramp down. She's looking really good. -6, -4, -3. Small negative.
Wait on
She's
gear.
on the ground.
Engine shut down.
Post landing.
Hey, PE, this is DFM.
Going final bit. Heaters are off. Engine out monitoring process initiated. Launch commit process initiated. 50 seconds. 45. 40. TM bit ground pass vehicle pass. 30.
Drains closed.
20. 15. 10. 9. 8. 7. 6. 5. 4. Start and check engines. 2. 1. Launch and flight. Seconds. Translation. 15 feet a second, looking good. halfway through. Starting the pitch maneuver. Landing low thrust. Landing Q limit. 200 feet.
Gears down.
Landing high thrust. Cell ramp down. She's looking really good. -6, -4, -3. Small negative.
Wait on
She's
gear.
on the ground.
Engine shut down.
Post landing.